What's up, Coding fam? It's Trill Manila, day 58 on the road to code. And today's topic for today is I learned about the solid methodology, which is intertwined with the Agile Architecture Revolution book that I read just a few weeks ago. And this is something I should have learned before learning about Agile. So, hype about learning this. And I picked up a book called Clean Code by Uncle Bob Martin, Robert Martin, who's also the co-author of the Agile Manifesto, which I just read about, and he's also pretty sure he created the solid methodology as well. So definitely a legend. I can't wait to read that book. But let's just get right into it. This is an article I have pulled up from hackernoon.com. Their article about solid. The S, Single Responsibility Principle, SRP in parentheses. A class should have one and only one reason to change. When requirements change, this implies that the code has to undergo some reconstruction, meaning that the classes have to be modified. The more responsibilities a class has, the more change requests it will get, and the harder those changes will be to implement. The responsibilities of a class are coupled to each other, as changes in one of the responsibilities may result in additional changes in order for the other responsibilities to be handled properly by that class. Bullet point: what is responsibility? A responsibility can be defined as a reason for change. Whenever we think that some part of our code is potentially a responsibility, we should consider separating it from the class. Let's say we're working on a project that helps people become more active in their community, and the system needs to have a social media integration. It'd be a good idea to separate the social media integration responsibility from the other parts of the system, as we should always be prepared for external changes. If you want to see SRP in action, check out this article by Plain Old Ruby Objects, which explains how SRP, alright, not important. Have you ever heard of something being open and closed at the same time? Well, I certainly have, so let's look at it together, which is the next letter, O, open close principle. You should be able to extend the class behavior without modifying it. This principle is a foundation for building code that is manageable and reusable. Robert C. Martin. How come something be open and closed? A class follows the OCP if it fulfills these two criteria. Open for extension. This ensures that the class behavior can be extended as requirements change. We should be able to make a class behave in new and different ways to meet the needs of the new requirements. Closed for modifications. The source code of such a class is set in stone. No one is allowed to make changes to the code. So immutable but flexible, which reminds me of Bitcoin, by the way. So continuing on. How do we achieve this? Through abstractions. In order to be able to extend the behavior of a class without changing a single line of code, we need to make abstractions. For example, if we had a system that works with different shapes as classes, we would probably have to have classes like circle, rectangle, etc. in order for a class to depend on one of these classes to implement OCP. We need to introduce a shape interface / class. Then whenever we had dependency injection, we would inject a shape instance instead of an instant of a lower level class. This would give us the luxury of adding new shapes without having to change the dependence class's source code. Alright, makes sense. The child should not be able to change the parent properties, pretty much. How do we know whether to make a shape a class or an interface? For that, we should go to the Liskov Substitution Principle, which tells us when inheritance is suitable. Let's take a look, shall we? The L, Liskov Substitution Principle. Derived classes must be substitutable. Substantiable or substitution. Oh, yeah, that's right the first time. For their base classes. What is wanted here is something like the following substitution property. If for each object 0,1 of type S, there's an object 0,2 of type T, such that all of the programs P defined in terms of T, the behavior of P is unchanged, where O1 is substituted for O2, then S is a subtype of T. Barbara Liskov. Let's visualize a definition with a case study. Let's say we have a rectangle class and we have a class that extends it, square. Let's say that rectangle has two methods, set width and set height, which will set the height and width of the rectangle respectively. The problem is that the behavior of the two methods differ between the rectangle and the square classes. The reason is that the square, by mathematical definition, is a rectangle with equal height and width, so the two methods will change the same value, whereas for a rectangle, they will change the width and height respectively, which are different values from each other. When we are using abstraction, open-close principle, we want the methods to behave the same for each derived class and not differently. In this case, we should clearly see that a square class should not be extending to the rectangle class because the behavior of the inherited methods differs. That makes a lot more sense when I first read it. The solution, as Robert C. Martin suggests here, we should design by contract. What this means is that each method should have preconditions and postconditions defined. Preconditions must hold true in order for a method to execute, and postconditions must hold true after the execution of method. When redefining a routine in a derivative, you may only replace its precondition by a weaker one and its postcondition by a stronger one. Bertrand Meyer. This is a clear and to the point explanation of the definition that I found online. 1. Assume that your base class works with a member int. Now your subtype requires that int to be positive. This is strengthened precondition, and now any code that worked perfectly fine before with negative ints is broken. Likewise, assume the same scenario, but the base class use the guarantee that member would be positive after being called. Then a subtype changes the behavior to allow negative ints, code that works on objects, and assumes that the postcondition is a positive integer is now broken since the postcondition is not upheld. Robert C. Martin suggests that it is helpful to document comments, the preconditions and postconditions for each method. Okay, so that looks like a useful time to comment, because in most cases you don't want to comment anyways. And now the I interface segregation principle. Make fine-grained interfaces that are client-specific. Clients should not be forced to implement interfaces they do not use. Robert C. Martin. In other words, it is better to have many smaller interfaces than fewer fatter interfaces. For example, let's say we have an interface called animal, which would have eat, sleep, and walk methods. This would mean that we have a monolithic interface called animal, which would not be the perfect abstraction because some animals can fly. Breaking this monolithic interface into smaller interface based by role, we would get can eat, can sleep, can walk interfaces. Okay, that makes sense. This would then make it possible for a species to eat, sleep, and, for example, fly. A species would be a combination of roles instead of being characterized as an animal, which would not necessarily be the best description at a larger scale. Microservices are a very similar case. They are pieces of a system separated by responsibilities instead of being a great monolith. By breaking down interfaces, we favor composition instead of inheritance and decoupling over coupling. We favor composition by separating by roles, responsibilities, and decoupling by not coupling derivative classes with unneeded responsibilities inside of a monolith. Now D, the final letter, dependency inversion principle. This one is a big part of it. Depend on abstractions, not on concretions. A, high-level modules should not depend upon low-level modules. Both should depend upon abstractions. B, abstractions should not depend upon details. Details should depend upon abstractions. That's deep. Robert C. Martin. Getting me hyped to read the book, but of clean code. Let's say we have a system that handles authentication through external services such as Google, GitHub, etc. We would have a class for each service, Google Authentication Service, or GitHub authentication service, etc. Now let's say that someplace in our system we need to authenticate our user. To do that, as mentioned, we have several services available. To be able to make use of all the services, we have two possibilities. We either write a piece of the code that adapts each service to the authentication process, or we define an abstraction of the authentication services. The first possibility is a dirty solution that will potentially introduce technical debt in the future in case a new authentication service is to be integrated to the system. We need to change the code, which as a result violates the OCP. The second possibility is much cleaner. It allows for a future addition of services, and changes can be done to each service without changing the integration logic. By defining an authentication service interface and implementing it to each service, we then should be able to use dependency injection in our authentication logic and have our authentication method signature look something like this: authenticate parentheses authentication service parentheses. Then we can authenticate by a specific service like this: authenticate parentheses new Google authentication service parentheses. This helps us generalize the authentication logic without having to integrate each service separately. By depending on a higher level abstraction, we can easily change one instance with another instance in order to change the behavior. Dependency inversion increases the reusability and flexibility of our code. Benefits. Following principles always has benefits. It is no different in software engineer. Following the solid principles gives us many benefits. They make our code reusable, maintainable, scalable, testable, and more. For more benefits of each of the principles, make sure to read Uncle Bob's articles. That's pretty much the end of the article, but now I do want to check out his articles. But yeah, that's pretty much the update for today. Day 58, chugging along, almost hitting that 2-month mark, almost at 100. But as always, just like, comment, and subscribe. And if you stuck around for this amount of time, thank you very much. And yeah, just thank you. Check out the GitHub, Trilla Manila, Twitter, Trilla Manila, blog, trillamanila.com. Peace out.
Trilla Manila!